Okay, cool. Okay, so welcome to CRTs. I am going to try to explain the basics. I'm not going to, can't go too deep into it because I'm only going to be here for an hour. Who here has ever repaired or worked on the inside of a CRT monitor? Okay, fair number of people. Who here is afraid of taking apart a CRT monitor? Yes, we have a lot of those. Okay, because you know the back cover of these things always says, you know, danger, high voltage, no user serviceable parts inside, and all sorts of other dire warnings. And you've all heard about the fact that they store a charge even when they're not plugged in, and that is true. That is very true. However, the chances of dying working on a CRT are relatively small. I've done this class a couple of times. I've warned people about it. I've told them if anybody ever gets killed working on a CRT, send me an email. Let me know how you did it. And I haven't heard anything back, so I'm sure everybody's fine. But seriously, it's yes, it would hurt. No, it shouldn't kill you. But I would avoid it if at all possible. But I'll tell you how to do it. Do it without hurting yourself. Okay, so basics. The screen is not up.
Oh, yeah, it probably needs to be turned on.
There's still no
It'll
screen?
take a moment.
Oh, okay. I just have some schematics here. I don't have like a slide deck or anything. I just wanted to point out some stuff on a schematic. Okay. So obviously I've got a couple up here, a couple of TV sets. All this applies to TVs, computer monitors, terminals. What?
You need the signal, don't you?
For this or?
Oh, for your computer to put things on
It's plugged in. There we go. Okay, so the same thing, the same principles of operation apply to TV sets, to terminals, to compact Macs, to VGA monitors, anything that uses a CRT. First, you have to start. You need power somewhere. It plugs into the wall. And on this schematic, it plugs in. Where'd it go? Right here. I know it's fuzzy, but it doesn't really matter. I'm just going to try to explain the base. So this is the schematic for a Sanyo arcade monitor. This was used in games like Donkey Kong and stuff. The AC comes in here. It gets rectified by some rectifier diodes, and there's a filter cap in here. And then there's a voltage regulator, current limiting transistor, resistor, and a voltage regulator IC that creates the B plus voltage. You'll hear the phrase B plus a lot when working in TVs and CRTs. B plus is the name given to the main voltage that runs the whole thing. It's in a monitor like this. It runs, I think, it's 120 volts. I forget.
It's 100, right?
Depends on the monitor. It's going to be. It might be 100. I think an Electro Home is at 120. I can never. 118 sounds familiar. And I don't care about the mirroring. It's going to be different depending on whatever you're working on. Some terminals, the B plus is 12 volts. Some TVs, it's 127, 120. Just depends on the set. The actual voltage isn't as important as understanding what it is, and that's the main power source you're dealing with. That's what everything runs from. And if something has happened to that, the picture will shrink, it will grow, it will be unstable. So if you're having anytime I'm working with a monitor, I'm not sure what it's doing, I plug it in, I check the voltage somewhere after this voltage regulator and try to see, okay, what is my B plus? Is it stable? Does it make any sense? In terms of the high voltage, everybody always talks about. So this is the Flyback Transformer. This is the component in the TV that generates the high voltage, and that is down here on the schematic, right here. This gets driven from the horizontal section, and schematic's really hard to read. I'm not going to bother pointing it out, but there is the horizontal frequency. You've heard of things like 15.75 kilohertz. That is the horizontal frequency of a standard NTSC TV, a CGA monitor, an arcade machine monitor, and a lot of other things. The Flyback Transformer is what is responsible for generating that high voltage, this big scary red wire that goes up to the tube. And that is driven, the primary of the flyback. Is everybody familiar with roughly how a switching power supply works? This is basically a switching power supply. Instead of having a transformer, a linear transformer that takes the 60 hertz AC line voltage and stepping it up, they're using a much higher frequency. The higher the frequency, the smaller the iron core needs to be, the less windings you need to make. So you can have a small transformer that puts out high frequency, high voltage. So that's this, the horizontal frequency drives the primary, the flyback, and then that generates the high voltage as well as the stuff for the other grids and the parts of the tube. The basics of how a CRT works is you have, this is the gun assembly out of a broken tube, and you can even see down in there's 3 separate little electron guns down inside there. Got a filament that gets hot and heats up the cathodes, and those emit electrons, and then you apply a signal to the input pins, and then that causes the enables, disables, modulates that beam of electrons. The high voltage is for the accelerating anode. This is like, usually on a TV like this is going to be something like, I don't know, 15 to 20,000 volts in a small color TV. A small terminal like a VT100 is only about 12 to 15,000 volts. Color is usually a higher voltage. So you have this high accelerating anode voltage applied here, and then the stream of electrons it gets accelerated from the gun to the face of the tube. And the inside of the tube is coated with phosphors. Whenever the electrons strike the phosphors, it makes them glow. And that's what forms the image. And it's scanned top to bottom. Scans the entire tube, goes down a line, scans the rest of the tube. And I'm sure you've seen, like, people, the slow-mo guys, there's a really wonderful video where they videoed the screen at high frame rate, and you could see the beam like traveling down the screen. The way it's moved around, so left to its own devices, the electron stream electrons would leave the gun here, travel straight toward the face of the tube, hit the tube, and leave a dot in the center of the screen. And burn it out. That by itself isn't too useful, so you need to somehow move the electrons around the screen. And that's done with this component. This is the deflection yoke. It's this copper coil on the back of the tube. There are 2 windings. One of them's on the inside, and then one of them's on the outside. And that would fit on the tube just like that. And these do the horizontal scan. These bend the beam left and right. And these do the vertical. And they bend up and down. And so you kind of have this whole like coordination going on, right? You've got the video signals being applied to the base of the tube here to create that pulsed beam. You have the deflection amplifiers moving the beam up and down the screen, and while painting it left and right across the screen. It's made somewhat easier by the fact that the horizontal scanning frequency is that 15.75 kilohertz, so that whole horizontal circuit is what's driving both the high voltage and the left to right movement of the beam. So that's why whenever you have a failure in the scan somewhere that kills the horizontal, you lose the high voltage. So you have, if you have a monitor that just doesn't produce any picture, but it's, there's no high voltage, no static on the screen, something probably happened to the horizontal or perhaps the flyback circuit. Other common problem with, I'll get into the common problems later. Let's focus on theory, I guess. This is a color TV, but black and white works just the same way. Color has the added bonus of higher voltages, 3 guns instead of 1, and then you have all these little rings on the neck of the picture tube right here, and these control the convergence. That aligns all 3 of these beams with each other so that they form one contiguous image. And purity, which means that the red beam only hits the red stripes. On the face of this tube, there's stripes of phosphor painted on the inside in 3 different colors. And depending on which stripe that hits, is what color you get. So it's important that the red gun hit only the red phosphor. This is being a color set also has the added bonus. There's an extra piece of metal in here, but behind the picture tube, or behind the faceplate of the tube, behind the phosphors, there's a grid, a shadow mask. It looks like a screen door almost. It's a piece of metal with holes in it. And that makes sure that the beams don't bleed over, so that the red beam hits the red phosphors and the green beam hits the green phosphors. And you've probably heard of degauss, right? Remember degauss on an old computer monitor? It makes the picture go funny. What that's doing is it's demagnetizing that metal shadow mask. That shadow mask has to be something that's magnetic so that the electrons will interact with it and it'll actually block them. But the problem is the Earth has a magnetic field. Every time we move a TV or a monitor through that magnetic field, it will pick up some stray magnetism. So every time you turn this set on, it has to remove it. And that's what this copper coil, this coil around the outside edge of the tube, this is the degaussing coil. This fires every time you turn a TV on. That's that thunk noise you hear. And that noise that the degaussing function on a computer monitor makes. And here's that coil that's been removed from a TV, from a bigger one, obviously. But it's just a coil of wire. It's connected to AC. And we can do this manually, too. So like this TV is just a regular TV. It's still on, right? And I'll put a pattern on it. Okay, so this is just your standard like color bars. And watch what happens when I turn the TV. Didn't all the colors shifted around, didn't they? And so now they're all wrong. But if I turn it back right, then the colors are right. And you can hear whatever junk is rattling around this particular TV. Now, if I turn this upside down, now those colors are all messed up. But I can clear them. This is a standalone degaussing coil. It looks complicated, it looks fancy, but it really isn't. It is, however, tangled.
How many turns of wire are inside?
I don't know. A lot. There's no circuitry in here. It's literally just a big coil of wire with a plug on it. So
leaving it turned on would be bad.
Correct. This gets very hot very quickly. You can only run it for a few seconds. Now imagine this was a TV that was moved and had a weird blob on it. I could turn this on. The technique for degaussing a TV is you turn the coil on away from the screen, bring it toward it, move it around, and then bring it away and turn it off while you're away. And see, now the colors are fixed. Ish. Yeah. Right. And then if I put it back right again, now it doesn't look so good because I degaussed it while it was upside down. So I can do the same thing again and fix it. There you go. And and so if you've ever had a TV that had a weird blotch somewhere in the corner or in the edge, it's possible one of these rings could have gotten out of alignment, or the tube might just need to be degaussed. This coil obviously looks like special equipment, but you don't have to buy one. Question?
Yeah, so when the colors change when you turn it over, is that just because it's changing its orientation with the Earth's magnetic field?
Yes. Electrons aren't affected by gravity.
But how come when I turn around backwards that doesn't happen?
It's
The magnetic field is like this. So the magnetic field is going.
So if I took that to the North Pole, would I have to turn it sideways for the colors to be right?
well, actually, that's
It's blowing my mind.
that's why. Well, yeah, actually. And actually, there were the factory alignments were done differently back in the day between TVs shipped in the northern hemisphere and in the southern hemisphere, for that reason. Or I pointed the wrong direction when I said that, but whatever. But that's why there's a degaussing coil that fires every time you turn the TV on.
Really note that I think my old vehicle's manual has that little north-south which way you're traveling.
Uh-huh.
I said if you go like a couple hundred miles or maybe 1,000 miles, if you're going straight on the highway, it's one thing, but maybe you'd have to take a few turns, turn around. It might be actually off, drift.
Yeah, it might.
And
Yeah.
have to realign itself.
Yeah.
Go on the block a few times so it gets bearings.
So the way that there's like I said, there's a coil in here that fires every time you turn the set on, and it's plugged into the circuit board. All this is an AC coil, and there's a thermistor, a component that increases in resistance as it gets hot, in series with the coil. So it has to have that tapering off effect. Like if I turn this on right here, the picture should be all messed up, isn't it?
Yes.
Yeah. See, the field has to go away slowly. It can't suddenly collapse right in front of the tube, otherwise it imprints that magnetic field on it. So the coil that are built into these sets, they tapers off as the thermistor, as the resistance of the thermistor increases, the current flowing through the coil decreases to nearly nothing. So like this looks like a specialized, expensive piece of equipment, and I mean, obviously this is something old I picked up somewhere. If you don't have one of these, you can make one, because remember, every TV has one of those coils in it. So if you take an old TV that you find on the side of the road, the bigger the better, because the coil is bigger, and then coil it up smaller, like that. Well, cut all the zip ties so it's not stuck together, and then put a plug on this. Like this is AC, 120 volt. Take a cord, splice it onto here with a switch so you can turn it on and off, or just plug it into a power strip and use that. Works the same way. And don't leave it turned on for more than a few seconds. It will get hot. It's not meant to be operated for very long, but you could. Please refrain from tasting the voltage.
Don't use a fork to connect it.
No, I would avoid that as well.
Have your friend make one.
But no, I've done this before many times, and it works perfectly. You know, and another option is if you have a really big AC drill motor, and hold that next to the tube.
Well, high output soldering guns.
That also that will work too. The trick is, I've heard of some other people say, oh, you can do it with a magnet, like a permanent magnet from a hard drive. No, that doesn't work. It needs to be a randomly changing magnet, or an oscillating magnetic field to demagnetize. You're not trying to magnetize. The other one I've heard is, tape a magnet to a drill and spin it in front of the tube. Just do this. It's easier.
Tape erasers.
Yeah.
Heard that one. Tape erasers.
A tape eraser is the same thing. It's an AC magnetic field. It will do the job, yes.
Cool.
Totally, a tape eraser will work. As long as you have a tape eraser, they're harder to get than old TVs.
The only your size thing might have something to do with it.
No,
That's the problem, is it'll be harder to get the degaussing.
Yeah.
it'll just take a few times. It's not that big a deal. But degaussing is that's a simple repair, right? You see something that's screwed up a little bit, you can do it without even turning it off.
Will it hurt it to leave it like this?
No, I'll fix it later.
But theoretically, if you just turn it off and turn it on, it would fix itself.
Yeah, if I turn this off and let it sit for 5 or 10 minutes, I'll try that. You saw how screwed up it was. I just turned it off. I'll let it sit for 5 minutes or so, let that thermistor cool down, and then it should be able to fix itself, or at least come close. As long as that circuit is working, which it should be, that should fix itself after a time or two, because the coil isn't super powerful. It doesn't run for very long. It's only for a second. But yeah, that'll totally fix itself.
Same upside down.
If you leave it upside down, one of the tricks that I used to do, or years and years ago, somebody leaves their desk for a while. You turn their computer monitor upside down. You use the degaussing function in the menu, boink it, and then put it back right side up again, and then all the colors are screwed up. And if they come back 2 minutes later and sit down and try to degauss the monitor, it's not going to work because the thermistor is hot because I just ran it. So okay, that's a simple kind of a failure, but it explains part of the theory as to what's going on here. The high voltage is what everybody's afraid of, though. So let me take this TV here. This is just a junk TV that I tore apart, so we can do some demos here. Let me plug this in. Make sure it still works. Should. Yeah. Okay. We got high voltage. You can hear it, and it's very fuzzy. This TV has some issues. It's slow to warm up, and but okay. So it's on channel 3. So let me put my test pattern on here and do some experiments while we've got it hooked up. Did I forget to plug in?
Did you find this on the side of red on the way over?
I wanted to take that when they drove by.
It did come from. I did find this in the trash. That's why it's all scraped up. It was all laying face down. I just grabbed it quick. I didn't realize it, but it's a good demo. It was a good test set for demos here. So I'm going to put on. Another problem you see a lot of times on TVs is it gets like this looks okay, right? But if I do this, and of course the controls are stuck. Come on. Okay, so this is the master brightness. This is the screen control. I'm adjusting the flyback here. Let me break the other one free. Okay.
Are you sticking that into the flyback transformer?
Yes.
Dude, you are so brave.
Well, so I normally use my fingers, but I couldn't because it was stuck. See, now I can turn it with my fingers.
Okay, it's
The
not
screw,
stuck in.
yeah,
Okay,
the screw itself is plastic. The flyback transformer is made out of plastic. I mean, it's still high voltage, and if there's a crack in it, I could hurt myself, but there isn't, so we're good.
I just brushed up against one of those before, and I had a shock, and I'll never forget.
And
Teeth are still chattering. They happen.
I wouldn't suggest people sticking their fingers into a TV unless they're really comfortable with what they're doing. I've been doing this for a very long time, and I know I'm comfortable with doing that but no, it's just a regular screwdriver. It's not. I mean, you see sometimes people have screwdrivers that are insulated all the way up the entire shaft. I guess it's nice, but I mean, the plastic handle of this is the Harbor Freight screwdriver, right? There's nothing special about, but the fact that it's plastic is insulating me. Now, I have seen some screwdrivers that have a metal core that go all the way through so you can pound on it. Don't use one of those if you're not careful, especially for the next thing I'm about to show you. But anyway, so the flyback transformer generates these voltages that the tube needs. It generates the high voltage for the accelerating anode, but it also generates the screen and focus voltages, and that is what I'm adjusting. That's what there's a resistor divider network in here, and it's like this is the focus. And see, I can turn it, make it all fuzzy. This affects one of the voltages that goes to one of the elements of this picture, of this tube gun.
Hey, Ian,
Yep.
you should also turn it and show them.
Oh, right.
It's okay.
So I'm adjusting this voltage back here with this knob. And that affects one of the voltages that goes to this gun. That it affects the focus of the beam. And it's kind of hard to see. Even right here, it's hard to see. But there's all these various little elements that interact with this electron gun. That's being focused here, yes. And then because the beam needs to be focused before it goes to the coil, because the coil just moves it around the screen.
I mean, in that thing you're holding, right?
Yes, it gets focused in here, yeah. And this is the gun. You can see the broken glass. This is out of the neck of a picture tube that's been broken. Yes.
Sorry to interrupt. Are the pinouts of picture tubes the same for all the different picture tubes?
Kind of, and yes. For over a range of them, yes. So they are. There's a lot of interchangeability, and I will definitely get to that.
Oh, I'm sorry.
No, that's okay. No, it's a really good question.
Since you were holding it in your hand.
No, it's a really good question. I do intend to mention that, and if I forget, remind me. So okay, this TV works, right? Now let's say I wanted to repair it. People always say, "Oh, well, you have to discharge it first," and that's the thing everybody gets afraid of, because you don't want to. They're afraid of the stored voltage. Because if I unplug this TV, you can hear this like crackle of the high voltage goes away, but there's still a charge stored in this thing. The picture tube still holds a charge, and if I disconnect this, if I touch this now, I'm probably going to shock the daylights out of myself.
The tube does or a capacitor?
The picture tube itself. So the picture tube, when you're talking about discharging a CRT, you're not. Let me turn this back on. You're not the thing that's actually storing the voltage is the tube itself, this glass tube. This high voltage connector hooks into a hole in the back of the tube, and then that connects to the inner coating. There's an inner metal coating on the inside of the tube, and then the outer coating here. Now this is grounded. I can touch this. This is fine. This outer coating is ground, and the picture tube's glass is the insulator. So it's a capacitor formed by these two plates with the glass as the insulator. Same thing that happens when you shuffle your feet on carpet and you go to touch, you're building up a charge and you discharge it through well, it's a bad example of a capacitor, but.
I'm sorry I was going to interrupt you again, because this is something I've been warned about by somebody else. I do old computers, and I try to get old TV sets and monitors to go with them.
Mm-hmm.
And I had somebody warn me up one side and down the other about something called a hot chassis.
Yes, this TV is a hot chassis TV.
Oh, but you can still I thought, what I was told, oh God, that's a hot chassis, don't touch anything on this.
I should be more careful, you're right.
Okay. I don't know, I wasn't warning you. I was asking.
I've already checked this, but this is a hot chassis TV. The problem with hot chassis is, this is a hot chassis design here, right? You've got the AC line coming right in, it's getting immediately rectified, and then that B plus voltage gets filtered. There is no galvanic isolation here. There's no isolation transformer. So if you connect any part of the circuit through here to earth ground, you will short out the AC line. You have a potential, a 120 volt potential between the AC line and ground. That's why this TV has no inputs. The tuner is isolated with capacitively coupled to the rest of the set. So the tuner is isolated, but the rest of it is not. So if I go poking around in here with reckless abandon, I can zap myself pretty darn good.
So are there no RGB mods for that kind of?
Do not, in any circumstance, attempt to RGB mod a hot chassis TV.
But it's got an RCA jack on it.
No, this one doesn't. This one does.
How did you just have it having signals in it?
I have a RF modulator here.
Okay, so, is that a clue? Because I was going to say, how could the outside of the RCA jack possibly be grounded if
So
there's no ground in there?
Well, there isn't. That's why there's no inputs on this set. This set has inputs. This is this set has inputs. This is a cold chassis set.
Is the antenna transformer coupled?
The antenna?
Well, no, so does that have an antenna input?
Yes, it does, and that is capacitively coupled
Okay.
to the rest of the set, which works for RF signals and not so good for other stuff.
There's no ISO transformer in this one. On the arcade games, they always have one in the bottom of the...
Correct, and that's because arcade monitor TVs arcade monitors are based off TV designs, and they needed the isolation transformer so they could connect it directly to the RGB. So in our arcade machines actually have a 1-to-1 110 volt isolation transformer in the bottom of the game. This is a Nintendo game, so it's actually 100 volts this monitor is supposed to run on, and the voltage transformer in the bottom of the cabinet steps the voltage down a little bit. But what I'm going to do now is I'm going to show you how to discharge one of these things without hurting yourself. So first you unplug it, always unplug it. And so then, what I'm trying to do is discharge the capacitor formed by the CRT. So notice this strap, this ground strap that goes across the back of the tube. That is connected to this graphite coating on the outside of the tube. This is called the aqueduct. And if I connect the screwdriver to that and slide this under there, hear that zap?
Yeah.
And that just discharged it. It shorted out the capacitor formed by the tube. It shorted out this through this clip lead to the aqueduct, this grounded graphite coating, and that discharged the tube. Now I can disconnect this without hurting myself. And you can see the way this connects it's like the top of a Christmas tree ornament. It's two little clippy springs that snap together, and there's a hole in the picture tube right here that fits into. I don't know if you can see that.
So if you're going to do cataract surgery, that's the first step.
Correct. You've got to discharge, you've got to disconnect it. And when people talk about it, a lot of times they'll say, oh, you're grounding it. You're not. You're shorting out the capacitor formed by the picture tube. Always connect the other end of the clip lead to either this strap that goes around the back of the tube, one of the metal mounting ears which the strap is attached to, something like that. I've heard of people trying to connect it to earth ground. You know, it's not going to work because it's like okay, you've got a car battery and you connect the positive to the ground. You're not going to discharge it because you don't have a complete circuit. So this is completing the circuit through the picture tube, shorting it out. Now it is safe. I can touch this.
Does it take a little chunk out of the tip of your screwdriver?
Nope, it's really low current. It's high voltage, but incredibly low current. Now, higher current stuff, like say a big capacitor. I'm sure we've all shorted out a capacitor with a screwdriver. Sometimes that takes a chunk out of your screwdriver. Yes.
So will this build a charge like a film capacitor would, or is it just discharging?
Well, it can through a process, I think electron migration or something. This gets history. Okay, this gets into physics that I don't understand because I'm just some dork that fixes TVs. But a big CRT, especially like a 25-inch, 27-inch, one of the big ones, when you discharge it, it will build a charge back up later. And not much of a charge. Like this. Yep, that got a little bit. It does build up a little bit of a charge. I discharged it, but there's still a little bit here. But it's like zapping yourself on a doorknob, right? It's minimal. It's enough to startle. It's like, oh, that's weird. But it's not going to hurt you because the current is so low because it's just.
So you don't have to like periodically redischarge it.
And you can if you don't want to get tingled like I just did. But you know, this is a tiny TV. It's low current. And once it's discharged the first time, whatever builds up again is not going to hurt you any more than being kind of surprising.
When we were working on Compact Max, like even if we weren't even working on the CRT element, that's something that you would just do, like if you crack that case and you were going in there, that was like the first thing that you did. So that you didn't.
And you could if you want, if you feel like that. I mean, if you want to, you can. I personally don't if I'm just working on something on the logic board or replacing a disk drive or something, because I don't need to touch it. Even when I'm fixing TVs, unless I have a reason to disconnect this, I generally don't bother discharging it. But if it makes you, but basically, if you feel more comfortable, go ahead and discharge it. You can't hurt yourself doing this.
You're pretty well insulated from the high voltage on that.
Exactly. I mean, there's nothing special about this screw. People will also say, oh, you need, they want special equipment or a high voltage probe or something. This is a Harbor Freight clip lead and a cheap screwdriver.
You're not a current limiting resistor.
None.
A lot of the arcade monitors self-discharge themselves, so they have a lead down resistor.
And I trust that precisely no times.
Normally you find disappointment when you try to discharge it.
Yeah.
It happens.
Some TVs do.
Surprised me that
Some,
this newer set would.
but you'd be surprised how many do not, or that circuit is broken. The Macs, some of them discharge themselves, some of them don't. Even if I know the monitor from previous experience does, I do not trust it. There's no reason not to trust it because it takes 30 seconds. Go ahead and do that. Now you can disconnect this. You can unhook this. So this is the neck board here. This has this isolated pin here. This is the focus voltage. This isolated one that's like off by itself. And you can kind of see it's inside this key. Because the focus voltage is like, oh, I heard a buzz through the audio.
It's just all right.
Oh, okay. The focus voltage is several hundred volts, like, I don't know, 400, 500 volts on most sets. So that is usually isolated and separate from that. So you can disconnect it.
Are you focusing across the whole plane, or is it like basically like if you, I mean, you know what I mean, like focusing the center versus having?
Sometimes you have to, depending on how worn out the picture tube is. So that's another thing I should mention is that as these tubes age, the electron guns start to wear out. They don't emit as many. The emissive properties of the cathode diminish. The spot size starts to increase, so you can't get that tight focus anymore. And then you kind of have to choose between whether you want the center of the screen focused, the edge focused, or kind of.
There's no fixing that.
Yeah. Well, there is. But wait, there's more. Yes. This is a Crt Rejuvenator, and this will basically charge up and zap the cathode and strip the outer coating off of it and allow the exposed new emissive material to extend the life of a weak tube.
So if you need 20,000 volts to make the cathode work in the first place, how much do you need to rejuvenate?
You don't need the high voltage to rejuvenate. That high voltage is only to accelerate the electrons from here to here.
So it's an issue of current to rejuvenate.
Yeah, it's applying it across the cathode, and it's trying to heat. What it'll do is it'll heat the filament up. It'll run the filament voltage higher, and then it discharges a capacitor basically across the cathode to try to burn it off.
Okay.
So it preheats it a lot, and then zaps it to try to clear that coating off. And if you've got a terminal or a tube that's weak or one color is bad, this can usually fix it for a while. Depends on the tube. Right? I've zapped terminals that were completely unusable and fixed them, and they work perfectly for years. I've on arcade monitors that use Zenith picture tubes from the 90s, that'll buy you a week.
And what can be repeated? Or?
It can be repeated until the tube wears out, which may be once, it might be 10 times, but usually it's diminishing returns. You know, this is kind of you only want to zap a tube that is dead, is dying. There's not really a way to fix it otherwise, and it's like, well, it's garbage anyway. There's also a chance to kill the tube with that. You can create shorts by overheating it. You can strip the cathode bare. It can ruin a tube that was kind of usable, but if it was already too weak to be good, then it doesn't really matter.
Is there material in there like there is for like a vacuum tube?
Yes, there is. It'll be inside the neck. Usually it'll be inside the neck here, hidden by the coils. Yeah, oh yeah, here's the getter. This is this would be flashed and it will be in there. And you could usually sort of see it inside the neck too sometimes. But yeah, there is a getter.
Have you ever used one of those on a Trinitron? I hear you're not supposed to redo it.
I've used it. Doesn't work, but I've used it. Trinitrons, not so much that you aren't supposed to rejuvenate, is that it almost never works. Yeah, I've tried it. I've gotten it brighter for like a couple of days, but it doesn't work. Something about the way the Trinitron guns are made. They're really good quality, but I think there's just that design limit that once it, I don't know why. I really don't know why it doesn't work on Trinitrons. But it has the adapter for Trinitrons. It totally works. It's just the other thing the tube tester, the rejuvenator can be used to do is just measure the tube. You don't have to rejuvenate. You can hook it up and see the emissions on a dial and see, you know, at what point, how worn out is this really. And sometimes you have a set with a really dim picture, and it's like, well, okay, is one of the voltages bad? Is there something wrong with the driving circuitry? Or is the tube is worn out? And I can use that to check. When it comes to like special equipment for CRT repair, I don't recommend. Most people don't need a picture tube tester, right? It's not the kind of thing that you need all the time. But a screwdriver and a clip lead, everybody should already have this. Really, the only tools you need are, you know, like this, screwdriver, soldering iron, basic stuff, multimeter. What?
And the signal generator is nice.
Well, the signal generator, yeah, this is really handy. I don't get me wrong, this is a really handy little device. But you know what also works? I have one here. A DVD player. This is just a regular old DVD player, and I have a test pattern disc in here. And this is what I use whenever I don't have.
Or you can turn this guy back on to see if he
Yeah. Let me plug this into here now.
Modern SBC can also work.
That's the wrong port. So this DVD has a bunch of test patterns on it, and it looks like the colors have fixed themselves.
Pretty much, you got a little bit of green in the upper.
Yeah. It's pretty close. And that was just from trying to get off and letting it sit for a few minutes.
So like next time it cools down, you hit it again.
Should be fine, yeah. But this is another, I mean, you don't need, I mean, this is, I happen to find this someplace. This is a really handy little device. It's just a little portable thing, but,
Yeah, they make really cheap boards that will just.
you can use it,
Add an RF modulator to it, and that's it.
yeah. So you can use a DVD player, you can use a game console. It also depends on the monitor you're working on, right? If you're working on a monitor for a computer, it needs to be connected to a computer that's compatible with it. You know, because this is just for, because it's just a, you know, obviously a DVD player with this thing only generates composite video. Having stable test patterns is handy, even on like when you're working on a terminal, for instance. There's not really a good way to feed other video into that. But what is easy to do is just fill the screen with lowercase m's, because that gets a whole bunch of stuff really close together lines, and you can dial in your focus that way. It's good enough.
In the old days when TV stations used to go off the air and run test pattern, go to sleep with a VHS tape in there, aim at that channel all night.
Yeah.
7 hours of tape, you got 2 hours just before you run.
So I'm just try to go into other stuff. Let me just tear this apart a little more here. I forgot to clip all these zip ties, didn't I? Hold on just a second.
On the side, the computers built into CRT, built into the same package as CRTs, I would highly recommend doing the discharge not only to avoid getting a shock yourself, but that logic board is easily blown out.
Well, that's why you have to discharge it to the CRT itself, not to system ground. I mean, technically they're connected together, but you want to limit the path. I've heard of people frying stuff by connecting the clip lead to the wrong place, and you can never go wrong by using the mounting ears of the tube, this springy strap. There's usually a spring on it. It's just a bare metal strap, and this is a graphite coating painted on the outside of the tube.
Does the spark ever like damage the graphite if it doesn't leave a mark?
No, it doesn't leave a mark. It doesn't even chisel away at the screwdriver. It doesn't. It's just too low a current. Let's see. This one has a soldered ground wire. I'm just going to cut that. But okay, so this is the chassis out of this TV. And there's nothing particularly special here, but this is a good kind of example of kind of your basic components. You have the flyback transformer right here. This is the voltage regulator. That's this chip here, which is this thing here on the schematic. This chip here, you kind of always figure out what's what in a TV or a monitor by just kind of following what things look like. Right, the voltage regulator has multiple pins, more than just 2, or more than just 3. This one has 4, and it usually says something like STR. This one says STR 30130. This is a 130 volt voltage regulator. This is the horizontal output transformer. This is what drives the flyback primary at the horizontal frequency to generate the high voltage. This transistor, if this dies, this will keep the flyback from getting the high voltage. It usually pops the fuse for the supply that creates the B+. So check this, so if the thing is dead, the first thing I check is to see if this is shorted out, or if the fuse has opened up. So that's a good way to look. Also, vertical problems. You ever had a TV that it worked, but the picture would collapse into a horizontal line, and then you hit it, and it would pop back again? Almost always, when that's the problem, it's this connector here, the yoke connector. This is what connects the, I was talking about, this is what bends that beam around. This yoke is what steers the beam around. And without the vertical connections, if one of those solder joints cracks, which happens just from, I'm not sure why, the frequency of the horizontal or the vertical, the heating, the cooling, something. If that connector cracks, it'll be the solder joint on the back of the board here. Then you'll start to get that. That'll be intermittent. It'll be then you can hit it and it'll pop back and forth. Another problem is the vertical, where it doesn't quite fill the whole screen vertically. It like stretches and squeezes. In fact, this TV has this problem, but after it heats up, it's fine. This is the vertical output chip. In this TV, it uses one chip. This is pretty common. It's this little module here with a bunch of little pins on it. But in some monitors, it'll be a push-pull arrangement of two separate transistors. If you look around here, these capacitors are right next to this chip, and they'll be connected to some of the pins of the chip, and one of these caps has gone bad. And that is why the picture squeezes up and down. And you can kind of read a chassis just by looking at the circuit board, because, for instance, in this one, okay, you've got C310, C303, C304. The chip, the vertical chip, is labeled as I301. Okay, so that means the 3 prefix is probably the vertical section. So even with, like, this isn't the schematic for this TV, but even without the schematic for this TV, I can look at it and say, okay, well, 301, obviously this is the vertical chip, I know what that looks like. And so these other capacitors that begin with 3 are in the vertical circuit, usually, not always. But you can look at other things. Here, like here's the horizontal transistor, this is Q402, and then the other stuff in that, here's C401, here's the linearity coil, that's L401. So I know that 4 is the horizontal circuit. That's how a lot of TVs and monitors are put together, and you can find out a lot about the way the set is built just by following the numbers. Not everything's like that. It's not a general purpose thing, but it was pretty common across a lot of different manufacturers and a lot of different eras. How much time do I have left?
15 minutes.
Okay. See, trying to think of other common failures. Anybody else had a TV that did anything weird, or a monitor that did anything weird?
Tilted, like if the video's tilted.
Oh, if it's tilted, that's a good question. The yoke is what bends the beam and makes it where it needs to be, and it's just this coil that's affixed to the back of the tube. So if you look here, there's a screw here, and if I take a Phillips head screwdriver and so there's 2 sets of screws here. This screw locks the convergence rings in place. And these are what align the beams with each other, the 3 colored beams. In a monochrome set, you won't have these. This is the yoke. This is what, that's what steers the electrons around. So if I loosen up this screw and rotate this will rotate the image. So if the image is crooked, all you have to do is loosen this up, and then even while the set is on, you can touch the plastic frame of it. Just make sure you stay away from these connectors on the bottom. If you touch one of these while the set is on, you will hurt a lot.
Seriously wish you hadn't done that.
Yeah, you will wish you hadn't done that, and you probably have a burn mark on your finger.
That happened to me when I was like 12.
But you can turn this, and however far you turn it, it will turn the image accordingly. So if the picture's a little bit crooked, and if you're afraid to do it while it's on, you can discharge it, you can turn it off, you can turn it a little bit, turn it back on, check it. Yeah, you can go through that.
It's 1-to-1 in terms of like its angle.
Yeah, yeah, it's a direct relation.
What about the convergence?
The convergence is set by these rings here. There'll be, I would say for reference material on the convergence, look up the service manual for the Electrohome G07 arcade monitor. The first couple of pages of that go over what all these magnets do and how to align them, and do a much better job than I could explain it. Basically, but these you'd put up a crosshatch pattern like I had on the generator, or just some white pattern, so you can see the corners and the edges, and you'd adjust these, and these will align the beams with each other, and they interact with each other. It's a kind of a pain. It takes forever.
Take a piece of,
So how
like
would-
a wax pencil.
Yeah.
And make a line on it first.
If your convergence is messed up, you're going to see different color fringes or something?
Yeah, you'll see different color fringes. Like a white line will have a red fringe on the edge of it, or something like that. In fact, I think this TV, if I remember correctly, had... Yeah, you'll have some kind of a... It's like, I think this... You can see you can get a little red fringing here. You can kind of sort of see it. I mean, it's a consumer TV. They're not perfect, and this one's been banged around a lot. But that's convergence problem, and that's you dial that, you adjust that with these rings here. There's also some strips that get inserted between the yoke and the tube that can kind of help you with the fine tuning of the corners. Convergence takes forever, and I could teach an entire class just on that. But I do want to get back to your question about cataracts. Who here has ever seen an old terminal or TV where the screen looks like it has mold in it? That is what's called as cataracts, or it's nicknamed cataracts because it's kind of like the same thing that happens to eyes, where it's something in it. On that type of picture tube, so this is a modern type of picture tube that it features integral implosion protection. There's a steel band stretched around the outside ring of the tube, and it's compressed. And that way, if something hits this really hard, if I throw a brick through this, it's going to collapse in on itself. It's not going to fling glass everywhere. Before they had the way to do that, they used a separate laminated safety glass, a separate piece of glass that was separate from the picture tube, that was glued to the entire front of it using like an epoxy resin type compound. It's called PVA, polyvinyl acetate. There's a couple of different formulations for this. Some of them turn green over time, and some of them deteriorate and start to look like mold. You get these like little blotches, and it'll start from the edge and work its way in. And the worse it gets, the worse the picture looks, and the worse sometimes you can't even read it. Like there's text on the screen, but you can't read it because there's all this mold in the way. The way to fix that is you have to separate that faceplate from the glass. And so the procedure is basically you have to take the tube out of the set. I lay it the neck down like this in like a trash can or something that supports the bell of the tube and lets the neck hang down inside. And you have to heat it up a lot. I use a heat gun used for stripping paint. Wear safety goggles, full face mask recommended, because if the tube implodes while you're doing this, it will fly, that launch glass everywhere. And you just heat the entire face of the tube. Try to do it as evenly as possible. Like I usually try to use like a halogen work lamp to preheat it for a while, and then go at it with the heat gun and slowly heat and heat. And at the edge of the tube, you'll see there's like a tape band. You have to take the tape off, like clear packing tape. And you can get in between the tube and the faceplate and use like just very gentle pressure with like a shard of wood, a chopstick, or something, and try to lever it a little bit. You don't want to put any real pressure on it because you can break it very easily. But you're basically, as you heat it, you'll see the air bubbles creep in from the outside until the air bubbles get all the way almost to the center. You can kind of work the bubbles around with the heat. And eventually the tube the faceplate will pop free. And you'll be able to lift that faceplate off, and you'll have this horrible smelling, very hot PVA compound trapped between the faceplate and the glass. And you have to clean all that off.
I've got a picture when you did one of these at a workshop last summer.
Yeah, actually, I should have, I remember that. I took pictures of it too. I should have gotten that ready and had it available. Yeah, if you've got it handy, you can go ahead and email it to me. But yeah, I did one of these at a workshop a while back on an ADM3A terminal that had that kind of separation. It's
One in my car.
yeah.
I'm going to be using it anyway.
The nice thing about the cataracts is the worse it is, the easier it is to fix, because the more it's eaten away, the less adhesion it has.
I had a question, Ian. What happens with it if you have a tube that has like a rolling artifact?
You've got like a band that like rolls through it once every second or so. That's usually something with the power supply, something with the filtering, like the main filter capacitor is not right, or the voltage regulator isn't regulating correctly. So I would start with the main filter cap. It's something very early in the power supply. You're getting AC line frequency into the power supply. Yes.
So, I have a terminal, it's a VT105, that
Correct.
It sounds like it has high voltage. When you turn it off, you can kind of hear that decay.
Okay.
Does that seem like a likely thing? Is there like another possibility that would be likely, or is it likely that I just don't know what I'm hearing when I hear it?
It could be that, but it also could be. Let me find the other schematic I wanted to show. I don't care about the Wi-Fi. So this is another schematic I use to demo this stuff. And I wish I don't know how to get the stuff out of the way, but this is the schematic of the DEC VT100 monitor. One of the big failure points in this monitor is, you can see here is here is the horizontal, here's the width coil, and here there is a capacitor right here. This is a bipolar electrolytic between.
18 volt, is that 18 volt cap?
No.
I don't remember that.
It's, well, this one's 25 volts, but it's usually somewhere between between 16 and 20 or 25. This one's 50. This is very common to a lot of monitor designs. Macintosh computers are notorious for this too. There's a capacitor right up at the top of the analog board on the Macs that dies. It's a bipolar electrolytic. It's usually about 10 microfarads or thereabouts. It's in the horizontal circuit. So you see right here, this is the horizontal output transistor. This is what's supposed to be driving the primary, the flyback. It goes through the width coil, through that capacitor, horizontal linearity coil, and then there's the yoke. And the flyback primary is over here.
So it essentially is possible to not have horizontal, but
Yes.
still have the flyback.
It would at least make a noise. You might not get any high voltage out of it.
Okay, so you would hear it coming on and off.
Yeah, you can kill it. But if this capacitor is dead, which it happens a lot, you will lose high voltage. You'll lose the picture. This happens in a lot of Macs. Sometimes it doesn't kill the high voltage in the Macs. You just get a vertical line. So if you've heard of vertical line disease on the Macs, it is the exact same problem. When replacing this, don't buy electrolytic capacitors. Get a quality film capacitor, a 10 microfarad like a WEMA brand or one of the other film capacitors to replace it. I've never actually used an aluminum polymer capacitor. I'm not familiar with them. I use like the polypropylene film or one of those types of film capacitors. I mean, it'll be like a $2 or $3 capacitor, and it'll be the PCB port pins, and it'll be too far apart, so you have to kind of bend it and fit it, but you can do it.
One of the things that we used to do on those is just go for what the voltage rating is way too low on that cap.
If you're using bipolar electrolytics, yes.
I think I threw a 50 volt cap in there. 10 years later, the sucker's still working.
Right, and that's the problem, is the bipolar electrolytics just do not hold up. The electrolyte solution boil.
Often when that goes, it burns the board and the diode next to it.
On this design, yeah, it could.
That's the one that I'm thinking about. It also takes the diode out.
Yeah, it could, totally, because the diode's right here. There's a,
Yeah, so you may have to check the diode. If it's still not working, I replaced the diode. I used, I don't know, one end of
not all monitors have the diode. The VT100 does. But the other nice thing about monitors when you're working on black and white monitors for like a terminal is you can reference the VT100 schematic if you can't find the right schematic, because there's only but so many ways to make a little monochrome monitor like this. They don't differ all that much. Yeah, the values will be different, but the general principle is the same.
And there are different versions of the VT100 depending on whether Ball made it, or there are multiple actual vendors.
Oh yeah,
sold the guts.
I know that, but this is close enough for most of it.
So, for example, in an arcade, when you play like a vector game, I'm thinking like Asteroids.
Mhm.
A lot of times it looks different.
The-
Very bright.
Well, a vector monitor is done completely differently. It's the same exact idea, same picture tube, same idea with a yoke to steer the beam around, but instead of drawing the signal with the picture with a bunch of lines, you are literally driving these coils separately like an audio amplifier. So the driving circuit looks much different. It looks like two separate amplifiers. And the horizontal is no longer tied to the high voltage. The high voltage is its own separate circuit with its own local oscillator, and the coils are driven directly by the game with an amplifier. So it can just draw, let's say you want a triangle, it just draws a triangle. And that's why it's so bright, because the beam only goes where it needs to go. It doesn't go over the entire tube and only turn on where it meets the pixels for the triangle. That's why it looks so sharp and so perfect.
That's also why it gets dimmer and more flickery, the more stuff is on screen.
Yeah, the more, if you have just a couple of items on the screen, it'll be bright and clear, but if you've got a whole ton of rocks going on the screen, then the asteroids gets a little dimmer and a little flickerier because it has to draw more stuff.
But is convergence on a vector monitor dealt with the same way?
Yes, it is.
Okay.
It's the same. It is still the same setup with these rings at the back of the tube.
And then
Just because electrolytics don't stand up to that kind of punishment very well, and we have better caps now.
It evaporates over time.
Yeah, the electrolyte breaks down. The film caps are solid. They don't wear out like this in the same way. In the 1970s, to get a 10 microfarad bipolar capacitor, electrolytic was about the only choice. But now, for the cost anyway. I mean, I'm still they're still cheaper.
Yeah, I just wonder why you were recommending it.
That's why they don't last as long. And also, most of the bipolar electrolytics you buy now are not rated for the high frequency. Because remember, this is getting constantly this is 15 kilohertz. It's constantly being exposed to all the time. And the modern bipolars are just these little tiny things. And they don't really like that high frequency very well.
So it's high frequency and high temperature.
Yes.
You mentioned before, super helpful actually. If you're trying to harvest an old monitor for RGB modding, like to not go for one that doesn't have a composite.
Correct.
Input. Is there like there's a chip that's in a lot of the ones that people are popularly modding? Like, do you know what that is?
Well, they're talking about the jungle IC, and that's just a general purpose term to mean the TV's control chip, right? Like this, here it is on this TV. Not all jungle ICs have the RGB pins brought out. Most of the time when you RGB mod a TV, you're going in through the on-screen display inputs. Not all of these chips have external on-screen display inputs at all. Some of them take digital inputs, and you're not going to get a good picture out of it. There's just so many TVs and so many different chips that were used, and so many of them are poorly documented.
Right.
It's kind of hit or miss. I've modified an awful lot of TVs, and I've found some that just are not worth the effort. And others like this is a hot chassis design. I would not try to patch into this directly, not unless you're running on an isolation transformer. You will fry stuff.
I mean, are there any like characteristics that might kind of pinch you towards whether it's more apt to be modded without having to?
Well, look for a composite input. If it doesn't have a composite input, I wouldn't bother with it. Like this set doesn't have composite, and I can look at the circuit and I can see, okay, there's one filter cap. You can see the power comes in. You've got a capacitor here. There's a rectifier, and one filter cap, a resistor, a voltage regulator. There's no isolation here. A TV like this has a switching power supply. There's usually two filter caps. There's a little switching transformer there. There's the chopper regulator, just like a switching power supply on a PC. It'll look like the PC power supply in a little section. And some of them even have marked off on the board. This is a Zenith, so it's not well labeled, but some of them actually have like a hot and cold section. They'll even be divided. You'll see it printing, dividing it, and then little opto-isolators that go from the hot to cold section for the feedback loop. So.
Chunks out of the board sometimes to isolate.
Yeah, exactly.
Keep in mind, if you're gonna convert a TV for RGB, you're still not gonna get as good a picture as you would on regular RGB monitor.
Yeah.
Yeah, it's not gonna.
But it seems people have really good luck. Like I say, if you find like a jungle chip or like someone was saying that maybe like picture in picture,
If it was
it's got like
really
some of
high-end
those-
TV,
but without like component input, you know what I mean? It's only got composite input, but it may have like a picture-in-picture feature, or it might have like
Right.
a fancier on-screen display that might be.
The RGB mod is only gonna overcome the limitations of the analog front end of that.
Yeah,
mod.
it's still a
It's not
TV
gonna-
set.
It's not gonna help you with the actual rasterization of the image.
Right, and it's still going to be like if you RGB mod a TV set, it's still just a TV set. It still has poor DC restoration. The picture's going to change with the picture size is going to change with image content. You ever notice that where you're watching TV and then a car commercial comes on with all that white text and the picture grows a little bit, and then yeah, you're going to be stuck with that. It's still just a TV chassis. It's going to look better than a TV did, but it's not going to look anywhere near as good as like a Commodore 1084.
Better than composite.
Somebody else had a question? Okay, yeah.
On the subject of prolonging the life of weak tubes, do you use brighteners?
A brightener is a last resort, right? Like if you've got a tube that's too weak to really use and it doesn't rejuvenate well, and you can increase. So what he's meant talking about is back in the day with old tube type TVs, there was a device you could buy called a brightener. It would go in between the CRT socket and the TV electronics, and it would, with a little transformer, it would boost the voltage. So you'd run a 6.3 volt filament tube at, say, 8 volts. And by running the filament hotter, you cause the cathode to emit more electrons, you get a brighter picture. At the expense of, well, now you're burning it out faster, you're going to wear it out faster, but it was already worn out. So it's use it if it's going to extend the life of something that was otherwise unusable. There's other tricks to that. You can. The filament on a modern TV is usually a winding in the flyback, and sometimes you can just kind of make your own winding and add another, turn or two. So that's a question?
So, just to be clear, once you discharge the CRT, feel like it's good at that point?
Yeah, it's totally.
It's definitely safe to get in there and start doing
Yes, the only other thing I would watch out for is any large capacitors on the circuit board. Like this big capacitor here, this is the main B plus filter, and this might hold a charge just like any other capacitor would.
But it's only charging 100 volts, not 1,000.
Correct, correct. But it's higher current, so you might get more of a zap out of it if you go to discharge it.
And then for vintage stuff, like 50s color stuff, I have a set that I picked up at the store. It's in really beautiful shape, and it's got a little misbehavior, but mostly works, just mostly bad picture and stuff. Are there caveats where you should have different techniques to work on vintage, as opposed to what you're
There's a couple of caveats for certain types of sets. For instance, discharging with a wire and a clip lead, this is good for almost everything. Those vintage sets, these newer sets, everything. The only time you shouldn't use a clip lead like this is if you're working in a game with mostly arcade games like Space Invaders, one of them. There's a stick diode in line with the output here, the solid state diode in some of the black and white designs. And that can be damaged by discharging it like this occasionally. If you work on a set like that, use either some resistors in line to bleed off the voltage more slowly or a high voltage probe. For the color TVs from that era, I work on an awful lot of TVs just like that. There's nothing particularly strange. You're going to find a lot more bad capacitors. The paper capacitors they used in that time frame were poor. They don't hold up at all. Yeah, use film capacitors to replace paper capacitors. For a 50s color set, yeah. All the paper capacitors and electrolytics would be the things you'd look at the most. But the electrolytics, you can measure your B plus voltage. You can get the SAM's photo fact for the set, get the schematics, make sure your voltages are good, and kind of work up from there. I think I'm probably trying for one or two.
I've got an ADM3A, and it's got a problem where the screen will be dark, but then when you crank the brightness all the way up, the text is actually black, while the rest of the screen is,
Sometimes that can happen when the tube is it dim? Is it like really dim?
Yeah.
Yeah, the tube is almost dead. When you crank it up that far, what'll happen is it'll actually drive the cathode negative. It's so worn out that it'll actually get that negative kind of image sometimes. But so if you leave the brightness down low, you can see the text. It's faint, but it's there, and it's normal.
You can barely even see it until you crank it, and then the text is like negative space. The text is dark.
That can also be a bad capacitor driving one of the cathodes on the tube. So I would check capacitors if you think the tube might be okay. If you have it with you, if you had it with you, I could check it. But it could be either the tube is really super zorched, or you've got a voltage that's too low driving the cathode, and that could be a bad capacitor.
If I could go back real quick to the question I asked before. Okay, so I've got a couple of ADM3As, and I've got one that's got a CRT that's in better shape.
Mm-hmm.
They're the same on the back.
Correct.
Okay, even if one is European 250 volt,
Yep, it's the same picture tube.
but it's the same picture tube. Okay,
Yep,
good. So
especially between the same model of terminal. Like, I wouldn't worry about that at all. But I've even taken tubes and swapped them between things as disparate as Apple II monitors and TVs and.
that was going to be I've seen people do things like, well, for instance, you had a VT100 up there before. I've seen a VT100 with an amber tube in it.
Mm-hmm. Yep, and I've been guilty of putting the tube from an IBM 5151 monitor in a Zenith TV. Yeah. Makes Pong really interesting. I've put you can swap the tubes around a lot, especially when it comes to monochrome tubes are very compatible. My trick for that is look up the documentation for the picture tube tester. This is a B&K 470, but if you look up the B&K CRT tester manual online, you can look up the picture tube numbers and see if they use the same socket adapter and filament voltage. As long as the socket adapter and filament voltage are right, chances are you can probably make it work as long as it's the same depth. Like Heathkit terminals used a shallow picture tube. Everything else was a little bit deeper. The deflection angle is different. Yeah. Worst case, sometimes when you swap tubes around, you get the G2 voltage or one of the like the G1 voltage is a little bit different, and it'll be overdriven. But you can sometimes adjust the circuit to compensate. But no, you can do all sorts of monochrome tube substitutions. But when you swap the tube, swap only the glass part. If you're going between like different monitors, let's say you take the tube out of a TRS-80 Model 3 and put it into an ADM3A, which does work. Just take the yoke from the ADM3A and move it onto the new picture tube. The yoke is pretty specific to the chassis it goes with, the copper thing. But the
Just
tube,
loosen that screw and it'll slide off?
yeah, it'll slide off. Some will be kind of sticky. You gotta be careful with it so you don't break the tube. Just kind of work it off slowly. Sometimes it'll be taped or glued a little bit, but you can usually get it off and it'll slide off. And you can swap the yoke, but the yoke needs to stay with the chassis. The tube itself is pretty interchangeable. Okay, I am officially out of time.
Great talk.
Thanks.